This is the brief on the Generalized Curl Theorem. So what is this thing? Well, think of the Generalized Curl Theorem as this: massive shortcut in physics and math. It lets you take a really messy, complex calculation across a whole surface and boil it down to a much simpler one that just follows its edge. First up, let's talk about where it comes from. It's actually derived right from the standard curl theorem. What it does is connect all the swirling changes happening across an entire surface. Think of wind over a hill, to just a simple calculation along the path at its base. The proof itself is pretty much a mirror image of how you'd prove the divergence theorem. Second, and this is where it gets really cool, this whole thing is a fundamental topological identity. So what does that mean? It means the result depends only on the boundary, not the shape of the surface in between. You could have a smooth hemisphere or a crazy rippled surface, and as long as they share the same edge, the answer is identical. The local vectors might be going nuts on that jagged terrain, but the global sum stays completely invariant. And finally, its practical use. This is a game changer because it lets you skip the hardest part of the problem. Instead of having to calculate every single bump on some jagged surface, you just compute one single circulation integral along that closed loop, the boundary. It perfectly captures the total twist of the field, and you don't have to worry about the messy geometry in the middle at all. So to sum it all up, the theorem proves that no matter how ridiculously complex a surface gets, it's only the boundary that defines the total circulation. In the world of topology, the edge tells the whole story.